Okay, hi, Assalamualaikum and salam sejahtera. Today, we would like to present our group presentation. This is for STQM2103 discrete structure. For this group project or pair project, we select division in integer. And my name is Muhammad FATHIMI IMRAN bin NORIZAN with metric number 285991. And my partner is Sarviin MAHESVARAN 284777. In division in integer, we have two types. This is greatest common divisor GCD and least common multiply LCM. And for these two, for GCD, it have two alternatives to find the solution. It is Euclidean algorithm and prime number. Why? For least common multiply, it only have one solution for this mathematical problem. It is prime number. So we will go for greatest common divisor for Euclidean algorithm. In GCD, for Euclidean algorithm, it have 3 points. First one is GCD for Euclidean algorithm is efficient method for computing the great common divisor GCD of two integer numbers. And the second one is the largest number that divide them both without a remainder. And the third is Euclidean is an adjective derived from the name of Euclid, an ancient Greek mathematician. Alright, so for question 1, I would like to find the greatest common divisor GCD of 32 and 60 using Euclidean algorithm. So let's go. Alright, in this solution, if you can see, if we want to find the answer, we need to calculate it until the right of the side get zero number. So first of all, we need to divide 60 by 32 and get the remainder of the 1 multiply 32. It is 28. And then we need to go step by step by the arrow in the slide until get the zero. Okay, so now we go for next step. So after we get the answer of 0, we need to look above the line of the 0. So we can see above the 0 is 4. So that's the answer for the first step. So we will go for the next step. For the next step, we need to find the solution with the formula is find D SA plus TB for this formula. And we need to exchange the position of this answer. So 4 will be the left one, and then 32 plus negative 1 multiply 28. After we get 4 by 32 plus negative 1 multiply 28, so we need to make it next step for get the answer. So if you can see in the right side, it have 4 by 32 plus negative 1 in bracket 60 plus negative 1 multiply 32. So in this bracket, we got from the highlight in the left side. So for the solution, after we settle the math problem in the bracket, we will get 4 equal to 2 multiply 32 plus negative 1 and in bracket 60. This is multiply. After we settle the math problem for 4 equal to 2 multiply 32 plus negative 1 multiply 6, we will get the answer for GCD 22 and 60 for Euclidean algorithm. The answer is 4. So 4 is the final answer for formula find D equal to SA plus TB.
And now I'm Sarviin. MAHESVARAN will be presenting about the solution to find greatest common division GCD with the prime number technique. Now we are going to apply the same question that we have used for the previous solution, which is Euclidean algorithm, and then we can compare the both answers to see whether the answers are same or this technique will give a different answer. The question is, find the greatest common divisor GCD of 32 and 60 using the prime number technique. So first of all, we should find the prime factorization of each number. To do that, we must take, and to start with it, we're gonna divide 32 using the number 2. The answer that will be given or obtained from the division must be divided till it gets to the number 1. So we're gonna try with number 2. So 32 divided by 2 will be 16. Okay, 16. Now we're gonna divide 16, and we should see whether we can divide with the same number or any other numbers. So this is the full answer for this for the division. So we could see 32, 16, 8, 4 and 2. These numbers, or the numbers obtained from division, can be divided from just one number, which is 2. So now we should, and the final answer is 1, which proves that the division is done. And now we're gonna see how many numbers, how many times the number 2 have been repeated. Okay, so as we can see, 1, 2, 3, 4 and 5. So the answer should be 2 with the power of 5. And now we're gonna divide the second number, or B, for this question. So we're gonna start with number 2 again, where 60 divided by 2 will be 30, and we're gonna continue the question with the same technique, where 30 divided by 2 will be 15, 15 divided by 3 will be 5, and 5 divided by 5 will be 1. So, and now we're gonna see the numbers that are used to divide, where the first number is 2 and 2 is repeated twice. The second number is 3 and the third is 5. So the answer should be 2 with the power of 2, and then 3 with the power of 1 times with 5 with the power of 1. So now we're gonna make the answers equal, where since or we're gonna make it balance, okay, for more precise, since there is no 3 or 5 for the number 32, we're gonna make it balance with adding 2 power of 5 times with 3 power of 0, and then times with 5 with power of 0. So as you can see, both of the answers have been balanced. And now the third method, which is multiply the common prime factors raised to the minimum powers to get the GCD, will be done, where we're going to choose the minimum value numbers between these numbers. Okay, so we're going to choose the number 2, the answer for number 2, where 2 with the power of 2 will be chosen, as that is the minimum value number compared between those two answers. And for the second answer, 3 with the power of 0 from the answer of 32 will be chosen. And for the third one, 5 with the power of 0 will be chosen from the answer that have been obtained from number 32. These are the minimum value numbers that are given by both of the numbers, and now these numbers will be multiplied to get the final answer, or GCD. And the question will be 2 power of 2 multiply with 3 power of 0 multiply with 5 power of 0, where the answer will be 4. And now, as we can see, the number obtained from the prime number technique is equal to the answer that we obtained from Euclidean algorithm, which is number 4. So hence proof that prime number technique or Euclidean algorithm will be giving the same answers to get GCD. Now I'm going to present about the second part of division in the integers, which is the least common multiple, also known as LCM. We're going to modify the question as find the least common multiple LCM for 32 and 60. For the GCD using prime number technique, we have chosen the minimum value number, but now we're going to choose the maximum value number. Both of the steps are same, but the only differences is lies at this particular part where we're going to choose the maximum value number instead of minimum value number. So now we're gonna get these maximum answers and write it as 2 with the power of 5 times with 3 with the power of 1 and times with 5 with the power of 1. So when we multiply these question, the answer would be 480. That's all from us. Thank you.